All right. Good morning, afternoon, or evening, everybody. Welcome to the Finding Your Tempo, an introduction to the mission, products, and data services for air quality observations over North America Earthdata webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we're going to go ahead and get started here. But what I'll do first is begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, please enter those into the Q&A panel rather than the chat if you have a question, but certainly you can reach out via the chat with anything. And you'll find that located on the right side of your screen. Today's webinar is being recorded. The recording will be posted both to the NASA Earthdata website as well as to our NASA Earthdata YouTube channel within a week of completion. And then once completed, I will send an email to all registrants with the recording links and also a link to this afternoon's presentation slide deck. The presentation slide deck will not be available for public distribution until a few days after webinar completion. So I know if you've attended our events in the past, that might be a little disappointing. However, we will make it available as soon as we can. As far as timing is concerned, today's webinar will be 1 hour and 15 minutes long, with 45 minutes allocated to the presentation and live demonstrations. We'll start with a 15-minute Q&A period, and we'll follow with an extended Q&A session, depending upon the volume of questions that are received. But we will have a hard cutoff of 3:15 p.m. During this afternoon's webinar event, we have 4 speakers. Our first speaker is Dr. Hazem Mahmoud. He is the science lead at NASA's Atmospheric Science Data Center located at NASA's Langley Research Center. Our second speaker is Dr. Caroline Nowlin. Caroline is an atmospheric physicist at the Center for Astrophysics, where she is a member of the Tropospheric Emissions Monitoring of Pollution, or TEMPO, instrument science team. Our third speaker is Dr. Gonzalo Gonzalez Abad, also an atmospheric physicist at the Center for Astrophysics. Dr. Abad leads the development of the TEMPO instruments formaldehyde retrievals and is a member of the Atmospheric Composition Instrument Science team. Finally, our fourth speaker for this afternoon is Dr. Daniel Kaufman. Dr. Kaufman supports the ASDC, and again, that's the Atmospheric Science Data Center, as one of the center points of contact for TEMPO, and he is also the ASDC TEMPO lead data scientist. Before I toss it over to Dr. Mahmoud to go over this afternoon's agenda, let's cover just a couple of notes regarding the Q&A session. We'll try to answer all questions within the time allotted, but if we are not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. With that, I am going to stop sharing my screen and introduce our first speaker this afternoon, Dr. Mahmoud. Azam, let me go ahead and stop sharing my screen here and pass the baton over to you.
Thank you, Jennifer.
You're very welcome.
Good morning, afternoon, evening, everyone. Wherever you are, and welcome to today's presentation to Find Your Tempo. This is Hazem speaking. In the next 45 minutes, we will introduce you to TEMPO mission, products, services, and resources at the Atmospheric Science Data Center for air quality observation over North America. Let me walk you through the agenda. Caroline will start us off with TEMPO mission introduction, then Gonzalo will go through TEMPO data products. After that, Danny will demo to us how to search the data, access and subset TEMPO data. And at the end, I'll give you more information about TEMPO resources before giving it back to Jennifer for question and answer. So now over to you, Caroline.
Thanks. So I'm going to give you a brief introduction to the TEMPO mission, and then Gonzalo is going to talk specifically about the different products available. Next slide. So TEMPO stands for Tropospheric Emissions Monitoring of Pollution. It's a space mission that's making the first hourly daytime air pollution measurements of trace gases over North America. And TEMPO was selected as NASA's first Earth Venture Instrument, or EVI, in 2012. TEMPO is in a geostationary orbit, which means that we can continuously scan the continent. So we can get high time resolution and space resolution measurements. And this is different from a lot of previous instruments or current instruments in orbit that people may have worked with before that are in low Earth orbits. And so those are about maybe 700 kilometers above the surface of the Earth, and they go around the Earth about 15 times a day, making global measurements, but typically always the same location. We measure from those instruments at the same time every day. But because TEMPO's in this geostationary orbit, which is much farther away, it orbits with the same period as the Earth's rotation, and so then we can continuously scan North America. We just don't make global measurements, though. We have baseline data products of ozone, that's total ozone and ozone profile, nitrogen dioxide, and formaldehyde. Next slide. So TEMPO's not up there alone. There's also the GEMS instrument, which was launched in 2020, and that's measuring over most of Asia. That was launched by the South Koreans. Sentinel-4 is being launched by the European Space Agency in 2025, and it will make measurements over much of Europe and North Africa. But we are working on the TEMPO instrument, so measuring from just below Mexico City to the northern parts of Canada. Next slide. So there's a lot of people involved in TEMPO. The principal investigator is Shang Liu. He's at our institute at the Smithsonian Astrophysical Observatory, which is part of the Center for Astrophysics. The founding PI is Kelly Chance. There's many partners from federal agencies, state and local air quality agencies, and there's 600 early adopters. So those are people who are applications users who have used proxy or simulated TEMPO in advance to get ready for this real data. So the science data processing and the instrument operations are done in Cambridge, Massachusetts at our institute. TEMPO is on a Maxar-built spacecraft, which is operated by Intelsat. This is actually the first time NASA has put a science payload on a commercial satellite, which is interesting. And the science data archiving and the project management are done by NASA Langley, and you'll be hearing from NASA Langley members later. Next slide. So the TEMPO timeline. So as I said, it was chosen in 2012. The kickoff was in 2013, and the instrument itself, built by Ball Aerospace in Colorado, was delivered in 2018. After that, it was integrated to the Intelsat 40E satellite and launched April of 2023. The first flight measurements were on the 2nd of August, 2023. So when you go to download this data, eventually you'll see that the measurements begin on that date. And nominal operations after a period of commissioning and testing various commanding started in October of 2023. In February, some people may have actually used this data already. We released a very preliminary 3 weeks of unvalidated trace gas measurements to the public. Those were from a week in August and 2 weeks in December of last year. The public data release is happening in May. So this week, there will be an announcement very shortly. The near real-time products we expect to be delivered in mid-2025. So those are short latency products, less than 3 hours from collection. The baseline mission itself is designed for 20 months. So it will be up later in the summer of next year, but then we can apply for extensions through the NASA senior review process. Next slide. So TEMPO has various kinds of scanning that you'll encounter when you look at this data. The nominal scans take an hour each, and that's when we scan the whole way from the Atlantic to the Pacific in 1181 east-west steps. There's always 2048 north-south pixels in the field, so no matter what scanning we're doing, you're always going to see the full north-south field. At the center of the field of regard, that results in a spatial resolution on the ground of about 2 by 4.75 square kilometers. It's a little higher or a little better over, say, Mexico City, closer to the equator, and because of the curvature of the Earth, the pixel size is about twice that size in the northern parts of Canada where we scan. The optimized scans happen in the morning and the evening when part of the other half of the continent is in darkness. We are just scanning about 2/3 of the continent. So in the morning, that's 2/3 on the east, and in the evening, 2/3 on the west. So you'll have slightly higher time resolution at those times of day of about 40 minutes. We also do twilight scans. If you're looking at trace gas measurements, there won't be results to download for this, but you can get the radiances. And those are to look at city lights at night. Those are performed during darkness before the morning scans. On occasion, there are high time resolution scans. So People can request very high frequency scanning, so up to 5 to 10 minutes just over a selected longitude. Those are quite rare. We've only done a few so far. There's another in 1 day in August last year and a few days in September. Those are rare. They have to have science team approval, because when those happen, we can't scan the full continent. Next slide. So this is an example, as well as that high time resolution of the high spatial resolution we get on the ground. So if you've worked with these kind of trace gas measurements before, you may be familiar with data from the low Earth orbiters GOM2, OMI, and TROPOMI. And this is a comparison of how their pixel size compares to TEMPO over the Washington, D.C. area. So the TEMPO ground pixel is about half of the size of a TROP-OMI pixel. However, we don't make the global measurements. We make high frequency measurements in time. Next slide. So how we make these measurements, I'll just mention very briefly before we move on to Gonzalo talking about the products. So these are measured, Tempo makes measurements only during sunlight for trace gases, and so we need sunlight to make the observations. So you're not going to see the trace gas measurements available at night. At the core of the instrument is this diffraction grating. We're essentially looking at reflected sunlight off the surface of the Earth and clouds, and we use those measurements in hyperspectral measurements, meaning that we can measure the full spectrum to derive the trace gases. So here on the left, you'll see what North America looks like this is an RGB image created from Tempo data. And this is what the Tempo's vantage point sees, and we have 4 sample spectra on the right. We actually take 2.4 million of these spectra every hour, so that's a lot of data to look at. And on the right, this is sun normalized radiance. So this is a radiant spectrum over those different points normalized by the solar irradiance. So that's the incoming solar irradiation that we look at once a week with the instrument. And you'll see the broad features are representative of the surface albedo, but what we're looking at for the trace gases is the finer features that are within those spectra. And now Gonzalo is going to talk specifically about the different data products available.
Okay, thank you very much, Caroline, and hi, everybody. Let me, as Caroline said, I'm going to be talking a bit about the Tempo data products. Last week, we put level 2 out there. Those are geophysical products, and since February, you can get access to level 1. First, I'm going to talk about the level 1 data. These are what we will call raw tempo observations after they have gone through radiometric calibration and geolocation has been assigned to it. Basically, it's tempo spectra that you can locate on the Earth on the surface of the Earth. This table summarizes the products that are available. The first one, dark, ERK, are readings of the CCD sensor of tempo when there is no light coming through the system. Those measurements are done or made to monitor the instrument health. Then we have the core of the observations, which is the sign observations when there is sunlight, as when it's sun. And these are similar, other than these are done when we are at twilight and dark. Those we cannot retrieve information about the trace gases or aerosols present, but we can look at the city lights, and it also helps us to understand how the instrument works, given the small signals that we are picking. Then we have another 2 sets of level 1 products. These are the IRR and IRR products. These are what Caroline mentioned, the solar irradiances. We also look directly at the sun. So we have a reference to then compare the observations from the Earth and extract the information about the constituents that are in the atmosphere. We make these observations using 2 different optical paths within the instrument. The regular observations are made every week, and then every 3 months, we use a different optical path to find out how the instrument is evolving over time. Finally, I want to mention that all these products, and also the ones that I will be talking about later, level 2 products, are at what we call beta maturity level. That means that the products have been minimally validated and they may be having significant error. So publication and research based on the data about the products is, you have to do it carefully, and publications are not recommended. You can have more information about what these the maturity levels are in the tempo validation document. Next slide, please. So now let me talk about the level 2 and level 3 products that are currently available. Level 2 products, as I mentioned before, are geophysical variables at the tempo's native temporal and spatial resolution. That means that we provide a piece of information for each part of the Earth that we measure. And level 3 products are similar to these ones, other than we have regrid them into a regular grid. In this case, we are using a 0.02 degree by 0.02 degree grid. While nominal sampling takes place every hour, as Caroline mentioned, Tempo can also perform optimized scanning in the early mornings and late evenings to avoid the areas that are still and are not useful for retrieval of trace gas information. I also want to mention that to speed up the processing of tempo and observations, these scans are broken in what we call granules. These are busy granules which contain information for 6 minutes, more or less. I will illustrate later how these things look, the scan and the granule, with an animation. For each data set, the most important variables are contained in the group, in a group called product, and Daniel later on will talk more about how to access. For now, we are distributing the NO2 tropospheric, stratospheric, and total columns, the formaldehyde total columns, and the total ozone total, and the ozone total column. And we also provide the cloud information, which we need to perform the retrievals of the other variables. Next slide, please. Tempo had some requirements as a mission, and this table here summarizes what we were supposed to achieve. And the good news, if you look at the 2 plots on the right, is that we do that very well. This is the top plot shows the uncertainty in the NO2 observations for each single measurement. And this histogram peaks well below 1e to the 15, which was the requirement for 4 quaded observations. And the one on the bottom shows similar information for the formaldehyde retrievals. This great performance is due to Tempo's great signal-to-noise ratio. I also want to mention that we are working and there are efforts to expand the suite of Tempo products with aerosol information like aerosol optical depth, layer height, and other trace gases like sulfur dioxide, glyoxal, or water vapor, to mention a few. Next slide, please. So in this image and animation, I saw 2 fields that are not the main product, but are useful to quality control the Tempo products. So in each, when we put out there the NO2 columns, it is important to be sure that you use the ones that suit your application and they are of the highest quality possible. To that end, we have included in the files variables such as the main data quality flag, the cloud fraction, the uncertainties, or snow ice fraction. It is important to filter each data product depending on which kind of application you want to have. And there is plenty of details about our recommendations in the user guides that are distributed alongside these products. Next slide, please. So now I want to show you 1 day of Tempo formaldehyde observations after filtering them by removing all the data that have a cloud fraction bigger than a quarter. And we have to do this because we basically cannot observe below the clouds. We need to see what is under the cloud, and when there's a cloud, we cannot do it. That's a consequence of using the UV and the visible. In this animation, you can appreciate how the first scans of the day, numbers 1 to 5, are using that optimized morning scan. And then you have the bulk of the day. And then at the end, you have scans 11 to 18, which are optimized scanning patterns for the late part of the day when only the west coast of the continent is illuminated. Because the formaldehyde signal is quite small, the retrievals are quite noisy, but quadrating information temporally and spatially will allow you to pick up signals that with LEO sensors tend to be much more difficult to see. Next slide, please. And I will finalize before passing the baton to Danny by showing you a similar animation for tropospheric nitrogen dioxide columns. First thing I want to mention in this one is that you see those vertical lines that happen along the scan. Those are the granules. So the processing is done for each one of those separately, and those are the information that come in the level 2 files. And then the whole east to west information, that's what is a scan, and that was the information that comes in a level 3 file. Finally, I want to say that in this image, we could zoom, but we are not zooming, but we could, and you will be able to see a great amount of information regarding the distribution of NO2 in urban centers and also how it changes along the day, which is one of the main applications for Tempo. And with that, I would like to pass the baton to Danny, who will do a demo. Thank you very much.
Okay, hello. I'm going to start sharing another window here, so that way I can do a demo. So hi everyone. I'm Danny from the ASDC, the Atmospheric Science Data Center at NASA's Langley Research Center. In this section, we're going to walk through the process of finding tempo data products on Earthdata Search. So as a preview of what's to come, we're going to walk through first Earthdata Search itself. Then we're going to talk about logging in to Earthdata, the capabilities for searching and filtering to find data sets of interest, to find the tempo data collections, how to find more information and details about the data collections, each one of them, and finally, how to download or to customize the way you want to access those files. So as a demonstration, I'm going to open up a new tab in this web browser and going to go to Earthdata Search, which is at search.earthdata.nasa.gov. And Earthdata, this is what it looks like when you first open it up. It shows a lot of other data sets, it doesn't necessarily start on tempo. But this is the primary access point for NASA's Earth observation data. So it has more than 100 petabytes of Earth observation data that are available in the NASA archive. So at Earthdata Search, you would log in first. In the top right corner, you'll notice a button that says Earthdata Login. If you don't have an Earthdata account, you can create an account for free. And you can do that by visiting the Earthdata login page, which can be found by going to urs.earthdata.nasa.gov. This is the same page that you would get to from that button on Earthdata Search, or you go here directly. Either way, if you don't already have an account, you could register for one, again, for free. This button at the bottom says register for a profile. So back to Earthdata Search, I would typically, in a typical workflow, I would click on the Earthdata login button here, and then put in the credentials that you've already set up for your account into the fields. And this will log in and then send you right back to Earthdata Search. Now, the Earthdata Search account, the Earthdata login account, is not necessary for searching for data sets or finding the information about the collections, but it is necessary for when you want to download files. So if you want to find the tempo data, you would often start by going to this search box in the top left corner. This you can type in keywords here. So we're interested in tempo, so I will type tempo. And what we'll see is that a pop-up appears, and it'll show options for filtering, either by instrument or by project. In this case, either one will suffice. You could do tempo as an instrument or tempo as the project. And once you click on that, it'll start filtering all of the available data sets. And here we end up with, it says 29 matching collections that match that tempo instrument filter. Now, tempo data sets are available from the Earthdata Cloud. So NASA's Earthdata Cloud is in the archive that's hosted in Amazon Web Services. If you wanted to find out more information about this, about the cloud itself, you could go to earthdata.nasa.gov/EOSDIS, which is one of the branches within NASA, and then Cloud Evolution. And this will bring up information about this Earthdata Cloud that hosts all of this data. So information about the benefits of the cloud, as well as background and more information to read. Not all of the NASA missions have data stored in the cloud yet. There's much of it is being moved to the cloud over a period of time. But for other data sets, you could click on this Available in Earthdata Cloud button on the left-hand side. That would filter the data sets to only those that are already in the Earthdata Cloud if you wanted to do cloud processing. In this case, all of the tempo data sets are in the cloud, so you will notice that the number of matching collections didn't change when I applied that Earthdata Cloud filter. So let's refine our search further here. Let's say we're interested in the nitrogen dioxide data. So here we can type NO2 into the search box and apply that filter. And here we've filtered now, we see 4 different data sets. And then other things that you might very well be interested in filtering by would be, say, time. So right below the search box is this calendar icon. If you click on that, it will bring up a way to enter a start and end time. So in this case, I want to show an example for May 14th. So we'll click on 2024, May 14th. And then it'll also bring up an available entry for time. So note that the times in Earthdata Search are in UTC. So there are possibilities where it might show one day, but the measurement time would be, the local time of the measurement might be a different day. So keep that in mind. Let's say if you are interested in the afternoon rush hour in Washington, D.C., which a lot of traffic in the afternoon around Washington, D.C., let's say we were interested in 3 o'clock local Washington, D.C. time to 7 o'clock. So Eastern time is 4 hours ahead of, or UTC is 4 hours ahead of local time in DC. So I would actually put in 7 o'clock for 7 o'clock UTC for 3 o'clock local. And this is in 24-hour format. So you'll notice I put in 19 for that. So now if we wanted to go for a 4-hour window here, put in the same day, and then add 00 here and press apply. And now we have a temporal filter on the data sets. Now we're down to 2 matching collections. And the number of granules for each of those collections is also shown right in this window here, where it says 37 granules for this data collection and 6 granules here. Now let's add a spatial filter as well. So we can press on this, it kind of looks like a cropping button right to the right of the calendar. And that allows us to select a rectangular bounding box. So you could draw a rectangle on the map. You could just draw it right there, or you can enter coordinates directly. In this case, I'm going to enter coordinates for a rectangle around Washington, D.C. by first entering the south coordinates for the southwest corner of that rectangle, and then the northeast corner. So that is 40.1 and negative 73.0. And once I press enter, it brings up that rectangle that I entered. You'll see it covers Washington, D.C., as well as areas south of DC, including the Atmospheric Science Data Center where tempo data are archived. Finally, we can filter as well by processing level. So Gonzalo mentioned the level 1, level 2, level 3 data. On this left-hand side frame, there's options to select or deselect different processing levels. So let's say we're interested in using those gridded observations that include the full east-west scans of the tempo measurements. So we'll select the processing level 3. And now we've filtered down to one matching collection with 4 granules that match all of these criteria. This is the tempo gridded NO2 tropospheric and stratospheric columns version 3 beta. And note that the newly available tempo data collection is version 3. That's this V03. Those data are available starting from May 13th, though, as Caroline mentioned, previous data back to August will be released once it's been reprocessed. So to find more information about this data collection, we can hover over the collection and select this I button in the bottom right of that collection frame. If we select that, it'll bring up a new frame that shows a bunch of useful information and links. So right below, for example, the dataset name is a short name, which can be useful for programmatic workflows. Then you'll see links, temporal information, format information, and so on. And I'm going to scroll down to the bottom, starting at the bottom. We also have a section here for cloud access. So this has information such as whether these data are available in the cloud, which they are. It shows the region within the Amazon Web Services cloud that the data reside. All NASA Earth Data Cloud data are in US West 2 region. It has the S3 bucket name, which is ASDC prod protected, as well as the prefix for all of the objects, the data objects for this dataset collection, for this one specific dataset collection, the NO2 tropospheric and stratospheric columns version 3. There's also a link to generate the AWS S3 credentials, and then also a link that will describe in more detail the in-region access, direct access to the data through S3. Note that this is unique to the NASA data center, which is archiving the data. So for tempo, these data are stored with the ASDC. So you'll see here that the URL given has data.asdc.earthdata.nasa.gov. But there's much more information here if you're looking for in-region direct access. Okay, now I'm going to click back over to the dataset information page, and I'll also mention at the bottom here is a For Developers tab that you can click, and it expands this a few additional links that may be useful depending on what you are trying to do. So for instance, there is the CMR API endpoint information here, which if you click on that, it will bring up the metadata for this data set collection, which has a lot of the specifics for this data set collection, such as time and data set information, polygons that represent approximate spatial boundaries of the collection, and so on and so forth. So this CMR is the NASA Common Metadata Repository. So this JSON resides within that metadata repository, which holds the metadata for the data collection, as well as all of the granules, which Gonzalo mentioned. The files are broken up into these 6-minute granules. So the metadata for those also reside within this CMR. So scrolling back up, we can access the Tempo Users Guide from this page. This is really important to keep in mind. This has very useful information. Gonzalo mentioned that this also has recommendations for using and filtering the data, but it has even more details such as the data processing, some details about the data processing, the data versioning, a brief description of the product algorithms, listing of the data products, their organizations and formats, as well as known issues. So this one that we linked to from the NO2 is specific to the trace gas and cloud products, level 2 and level 3. And you can see this was put together by the Tempo Science team and Tempo Ground Systems team. Back on this page, this dataset information page, another useful link at the top here is the View More Info, which brings up more information from the Common Metadata Repository. So this has information such as the variables that link to metadata for each of the variables within a particular data collection, as well as a documentation tab that also links to the user guide as well. Okay, now for now, let's say we are interested in getting the download links or accessing those specific data files within this collection. So at the top of this dataset info section, we can click on the search results button, and this will take us back to the list of datasets that matched our search criteria. So clicking on the dataset itself, here again, it's the Tempo gridded NO2 tropospheric and stratospheric columns. Now we see a listing of the files or those data granules that are part of the dataset. In this case, since this is the level 3 data, if I zoom out on this map, you'll notice that the level 3 data is each file here is an entire east-west scan of the Tempo field of regard. But let's say we are interested in getting 3 different time steps or 3 different measurements over this rectangle that we are interested in. So we would select 3 different of these scans by clicking this green plus in the bottom left-hand corner. And those add each of those files to our order of data. Additionally, you could also select, if you were interested in only one, there is a button next to the green plus that says download single data files, which will give you a direct link to download, or the AWS S3 URL as well. But if you were selecting lots of files, you could select them by just hitting the green plus and then pressing this green download button at the bottom right. So now that we've clicked that button, it will add those 3 granules to our order, and it will bring up this new page that gives us some options to customize our download. So first is an option to customize the options. Alternatively, let's say we are interested in downloading the entire file contents, so we can go right to download all data. And this will show then that there are no customization options for this selection. So we can click on the download data button in the bottom left, this green button here. This brings us to the final page for actually downloading them. So you should see, once this populates, you'll see 3 different tabs. There'll be a tab for downloading files. There'll be a tab for AWS S3 access, and then a file for downloads, the download script. The download files, the download script tab, these both are ways to download the files locally. So if you're interested in processing them locally, you would go to, say, let's start with the download files. This populates with the HTTPS links for each one. If you click on each one of these, it will start a download immediately. The download script is a convenient way for downloading like many files. Let's say you added hundreds of files. You could copy this script with this copy button, and you'll see that it is a script that could be executed in, for instance, a terminal window in a shell, and then it would loop through and download each file with only having to execute it once. The AWS S3 Access tab gives you the URLs for each of the granules in S3. So you'll notice that it starts with S3, the S3 bucket name, ASDC prod protected, the object prefix for the collection, and then the specific granule identifier. Okay, so many of the tools and services for accessing data through the Earthdata cloud are being migrated, or they're being developed in the cloud. The NASA data centers historically have done a lot of the processing on premises at the data centers, but now that the data are being moved into the Earthdata cloud, by doing the processing in the cloud next to the data, there are a lot of efficiencies that can be gained. So this includes the Harmony API. So the Harmony API is a service provided by NASA Earthdata, which provides access to subsetting, concatenation, OpenDAP in the cloud, as well as other services, just to name a few. So information about Harmony can be found at harmony.earthdata.nasa.gov. This page has information and links to examples of how to use Harmony programmatically. So for instance, by clicking on this View Jupyter Notebook demo, as well as documentation on it and the API, and brief descriptions of its features. So if we go back to our project page here in Earthdata Search, where we were looking at the data files, when you click on Customize with Harmony, this is actually going to run the services using that Harmony API. Alternatively, you can interact with Harmony programmatically, as shown on that Harmony webpage. But this provides an easy way to leverage the capabilities of Harmony through this graphical interface. So if you click on Customize Harmony, then we can select a service that will run in the cloud to process the data. So here, when we choose a service, we'll see that there is one service available for this level 3 data. And this will be determined by what particular data granules have been selected. But this service, it gives us an explanation of this service right below. It says that it performs variable, temporal, bounding box, and polygon subsetting on geographically gridded level 3 and level 4 data. So this is great if you wanted to retrieve only and extract only a portion of the data. Going back to our use case example of Washington, D.C., this would then subset the data to that rectangular region around Washington, D.C., and then also apply the temporal subsetting, the temporal domain ranges that we applied when filtering. So you can see that this spatial range is already preloaded in here based on our search criteria, as well as the spatial subsetting. If you selected or deselected either one of these, then that would determine whether or not the subsetting will be applied before giving you access to the data. Additionally, you can select only a subset of the variables that are in the files by clicking this Edit Variables button. So in this case, let's say we select the latitude and longitude, the entire product group, and time. And Gonzalo mentioned the product group is where you'll find the primary observational data. So here for the nitrogen dioxide files, the vertical column stratospheric estimates and vertical column troposphere, as well as the uncertainty and the main data quality flag, which are really critical for looking at high quality data. So once you've selected which variables, and we already have the spatial and temporal ranges here, when we click download data, this will kick off an order to that Harmony orchestrator on the back end, which in turn kicks off this POS geographic service that does the subsetting. Now, this will take a little bit of time. So let's, while that's going, let's take a look at the results from when I did this exact order just earlier. So what I'm going to do is open up the resulting file in an application called Panoply. The Panoply is a viewer for NetCDF files that's been developed by NASA for quickly exploring the NetCDF data. Panoply is accessible from giss.nasa.gov/tools/Panoply. Here you can download the latest version of Panoply and also see more information about it. What we can do with this here is we can look through the downloaded file and see the structure of the file itself in sort of a hierarchical format, where we have the granule that's been downloaded, as well as only the variables that we selected since it's been subset. So we see latitude, longitude, and time, and then the 4 variables within the product group. More information about all of the variables are shown on this right-hand side as well. So let's say we were going to look at the vertical column tropospheric measurements. We can actually double click, and Panoply will make it very easy to plot these on a map to look at. So we can see in this map that the subset was successfully applied, because we just see a region around Washington, D.C. That's this rectangle that we requested. Okay, so now going back to the project, let's look at level 2 data now. So when we're here, we can click back to project, and then on the upper right hand side, we can click back to search to then go for to modify the filters to look at level 2 data. So on this left hand side where it says level 3 gridded observations, I'm going to unselect that and then select instead the level 2 processing, or processing level 2. So that way we change the filtering and just get the level 2 data here. Okay, and then that's going to take a moment to change over from unselecting to then reselecting. Let's see, once we apply that, we should probably only see one data set, one data collection available, since we only saw one from level 3 as well. So here is the data collection here with 6 granules instead of the 4 for level 3. And that's because we're looking at individual granules, the individual 6-minute granules instead of the full scan. So just like before, we can click on this I button to find more information about this data collection, this particular level 2 nitrogen dioxide data collection, and we can click on the collection itself to see the listing of the granules. And we can either decide to add all of them, or we could search through for the particular granules of interest. Note that you'll see in rough approximation of the granule boundaries shown on the map. And you can see that there are 2 granules that intersect with the rectangle of interest here. But you'll see 6 granules here because this is 2 granules for each hour, or approximately for each hour of the scan within our time window that we selected. So now if, let's say we wanted to download all of these, we can just hit this download button at the bottom right, and this will add all of those granules to our project that where we are customizing the download. First, I think we're going to want to remove the level 3 files that we had added previously, because those are going to still be in the project and we haven't removed them yet. So once I'm able to do that, then we'll walk through the same steps to download these files and customize the download just like we did before. We're going to look at the customization using Harmony. So here we see the 6 granules here. And this one then is the 4 granules. The 4 granules was the level 3. So I'm going to remove that and just focus on these 6 granules of level 2 data and press the Customize with Harmony. And then just as before, we can choose a service. You'll notice that the service is maybe different depending on which particular data product is being requested. So here there's a service called Samba that performs subsetting and concatenation on level 2 granules. The options for this service are shown below, just like before. There's an additional option here that's enable concatenation, and this will concatenate the files using a particular type of concatenation that's been applied for tempo, so that way it concatenates both the granules within a scan and then across different scans as well. Also, like before, we can edit the variables, so that way we're not downloading the entire files, which may be quite large in size. So we can select the variables within the geolocation group for latitude and longitude and time, and then say we'll download the whole product group as well. And when we we can, when we're ready, we can select that green download data button, and this will again kick off a new order to the Harmony orchestrator that in turn kicks off that Samba service in the cloud next to the data, so that way it can apply those subsetting operations to the data, transform the data, and then make it available. This will also take a little bit of time. So while that's running, I'm going to open up the result of that from when I ran this just earlier. And you'll see here that in the geolocation group for the level 2 data, we have latitude, longitude, and time, as well as the whole product group with the data measurements and the main data quality flag. You'll also notice that a new variable called subset files was added, and this is because this corresponds to the 3 different scans in those six granules that were part of the request domain. So since there were 3 scans, a new dimension has been added to the files. So if we go to one of these data products, vertical column troposphere, on the right-hand side here, it shows the dimensions of this data. There are 3 dimensions. There's the original cross-track north-south dimension of the data file, the mirror stepping, the east-west stepping dimension, and then the subset dimension, which was added by Harmony and Samba, so that way the files can be merged together into one, but still retain those the scanning dimension. Okay, so with that, thanks so much for following through this data access section with me. In the interest of time, we're going to leave additional details about programmatic and GIS workflows for future content, maybe another webinar, maybe other trainings. But with that, I will hand it over to Hazem.
Thank you, Danny. In the next few slides, I'm going to talk about tempo resources at the Atmospheric Science Data Center. So following each tempo scan of North America, Intelsat 40E transmits the data to the ground station using binary system. Subsequently, the science team at SAO initiates the decoding to generate level 0 data and then elevate it to higher processing levels like level 1, 2, and 3. This processed data is then pushed to the ASDC's Dropbox for ingestion by our Cumulus ingest system. The system archives the data permanently at Virginia and ingests a public copy to the Earthdata cloud mentioned earlier using AWS US West 2, which is located at the state of Oregon. Once the data is accessible, users can download it via Earthdata Search as demonstrated earlier. Additionally, users can subset the data using OpenDAP, Harmony, and furthermore, you can do further visualization of the data using Worldview and Earth Geographic Information System, or EGIS for short. Tempo marks our first mission utilizing the AWS or Amazon Web Service Cloud. Tempo integration with AWS infrastructure opens up a lot of exciting possibilities for comprehensive data analysis, Users can leverage resources like EC2 stands for Elastic Cloud Computing for short, and you can perform advanced analysis and modeling. And usually, if you have any question, you should go to Earthdata Forum. Earthdata Forum stands ready to address any inquiries or concerns. We are committed to facilitating your research endeavors and maximize the impact of tempo data in advancing our understanding of atmospheric composition and air quality dynamics. The Earthdata Forum provides a central online location where data users can interact with subject matter experts from NASA distributed active archive centers to discuss data applications, research needs, and get answers for their questions. Any related questions to the data accessing, visualizing, manipulating. If you have any questions, we encourage you to visit the Earthdata Forum. There you can check if your inquiry has been previously addressed. In the event your question hasn't been asked before, or if the existing answers are outdated, or you feel like you have a new question that has not been presented before, please post your question as a new post, and our subject matter experts are committed to promptly respond to your inquiry, often within a matter of hours. Another very important source of information is navigating our website, asdc.larc.nasa.gov. Then you can go to projects. We have more than 100 science projects, and then choose tempo. So you'll find a wealth of resources for exploring and analyzing tempo data through tools like Earthdata Search. Users can easily locate and download tempo data sets, advanced functionalities like OpenDAP and Harmony presented earlier to subset and manipulate the data. SAO also is maintaining a comprehensive tempo daily log during nominal operations. This log serves they are detailed records of the instrument performance, data acquisition, and any important event encountered during the mission. On the landing page, you will also find and discover algorithm theoretical basis documents, ATPDs, user guides for tempo, and data validation updates. Other resources, on the top left here, we have the Harmony services offering convenient options for data subsetting aggregation alongside programmatic access facilitated by Harmony Python library. In the top center, worldview.earthdata.nasa.gov, Worldview takes the spotlight as a powerful solution for imagery and data visualization, seamlessly integrating with various satellite data sets. Worldview hosts the key variables discussed today, mainly NO2, nitrogen dioxide, formaldehyde, UV, ultraviolet aerosol index, ozone, and cloud cover. On the top right, gis.earthdata.nasa.gov provides a powerful tool set allowing users to pull mosaic data sets directly into the local ArcGIS Pro or even QGIS environment for in-depth analysis and even machine learning. Moving to the bottom left, Earthdata Search stands ready for seamless data filtering, web accessing, downloads. The bottom center, OpenDAP, mainly for temporal subsetting capabilities, enhancing accessing the data and more usability of the data. Lastly, in the bottom right corner, RSIG, not only does it offer executable software for data subsetting and visualization, but it also supports the integration with EPA, Environmental Protection Agency ground sensors data, and support programmatically access through the application programming interface or API. All of these resources, services for tempo data, they are shown step by step in videos in the story map. The story map is titled Air Quality Monitoring from Space by NASA using tempo. We can scan this QR code to take you to the story map, and it will be also added to the chat. So in the end, I want to thank you all for your time, and I'll give it back to Jennifer for the question and answer.
Okay, thank you so much. So at this point, I'm going to go ahead and open the final optional polls. Let me go ahead and do that. And let's jump right in because we are a tiny bit behind schedule here. All right. So the first question was actually asked in the chat. And it is there a plan to, is there a tool for subsetting level 1 tempo data?
Currently, we don't have a level 1 subsetter, but this is something that we can develop in the future if we have a lot of requests.
Okay, thank you. There was also a question, is there a plan to expand this mission globally? Which I know the answer to, but maybe future missions. I don't know if the science team could speak to that or on the call here.
I think Caroline can answer this question better. She was showing the slide with the sister missions of Tempo.
Hi, yeah, great question. So if you look at, when you get the slide deck, if you look back to one of my slides, there's currently a mission over Asia making the same kind of measurements as Tempo. It's actually a very similar instrument, and there's one going up in 2025 to measure over Europe and North Africa, but you'll see that there's definitely some pretty large parts of the world that do not have a geostationary trace gas observer. So there is an effort in the community to plan missions for over Africa and the Middle East, and then hopefully eventually South America as well. But there's nothing officially happening right now.
Okay, well, thank you so much, Caroline. Let's go ahead and jump down to the, we have quite a few questions in the Q&A panel. So I'm going to, and I'll skip back to make sure I'm not missing any, but in the spirit of time, let's jump in. When will the level 2 and level 3 SO2 data be available?
Yeah, I guess I can take that one as well. So right now, our next product that we're working on is the ozone profile for release. We then, there's been a need identified in the community for near real-time products. So we're working on the near real-time trace gas products next. SO2 is currently a research product. It's being developed by our Tempo Science team colleagues at NASA Goddard. Eventually, we hope to integrate it into a formal pipeline, but that probably won't happen, I would say, for maybe a couple of years. I probably shouldn't give a date, but it'll be a while still.
Okay, thanks so much, Caroline. And just going back to the first question I just asked, it was posed also in the Q&A panel, and I missed the second part. Getting to the level 1 data, it said also, do the Earth radiances have the DRK subtracted, or do we need to do this ourselves?
I can answer that one. So the level 1B RRD, they have already been, the dark current has already been taken into account, subtracted. So yeah, they are ready to be used in retrievals and other applications. But you can also get the dark current if you feel curiosity of it.
Okay, thank you, Gonzalo. Okay, so the next, let me scroll down here. Make sure I'm just making sure I'm not asking a question that has perhaps been answered by already been answered by Caroline or others from the team. Okay, so there was a question earlier. What does the term temp mean? Can you explain it briefly? And I'm not sure, perhaps somebody has answered that question. I think that question was asked during Danny's demo, actually. So you might, the user might need to provide a bit more detail, the participant in the chat, if you could add to this.
Yeah, I'm not sure with just that.
Okay, let's move on to our next question and I'll hop back to it. So the next question is, why is the available data so sparse?
I'm not sure. Does that mean sparse and spatially? We can't or sparse in time. Spatially, often when we plot the tropospheric data, we filter out the data that has a high cloud fraction, and this is because we can't measure under the clouds very accurately. So there is data there. So for instance, if you're looking at nitrogen dioxide, there's nitrogen dioxide in the stratosphere. And so, so that data is useful. We're still seeing nitrogen dioxide. However, if it's near the surface in the troposphere, it may be partially or fully obstructed by clouds. So it's the data could be useful for some people who want to do certain applications, but for most people who want to look at tropospheric nitrogen dioxide or formaldehyde, for instance, then you need to filter by clouds.
Okay, thank you, Caroline. So the next question is, how should the data be visualized? Should it be done through Panoply, the Remote Sensing Information Gateway from the EPA, or ArcGIS? If done through the, I don't know if the acronym is RSIG or if they pronounce it differently, how can we obtain a key to use the tempo data?
Yeah, so I'll talk to that. For RSIG, the EPA Remote Sensing Gateway, there's no key necessary, and was just discussing the visualization aspects with another fellow of our team, Georgina Hayes-Krebs. Wanted to stress that the worldview is an excellent way for viewing the imagery from Tempo, great for browsing through it and looking quick views of like what's there and where is their coverage. ArcGIS and the Living Atlas from ArcGIS has the data that's behind the imagery, so it can be really useful for analyzing the already filtered data. RSIG does provide subsetting capabilities as well, so another way, and is maybe useful for comparing tempo with ground-based measurements and other measurements that are available through the US EPA, Environmental Protection Agency. The Panoply tool is great for visualizing and exploring those NetCDF files. So if you're interested in digging into more the original, the raw data files, Panoply is really well suited for that. Alternatively, then you could programmatically make visualizations using any of the programming language of your choice.
Okay, well, thank you so much, Danny. So our next question is, I am curious why Tempo does not provide vertical column troposphere. It's really a comment, but if the science team or someone could weigh in on this. I'm curious why Tempo does not provide vertical column troposphere of HCHO like Tropomi does, but only provides total column for HCHO. Would either of you like to weigh in on that? Thank you.
Yeah, it's just it's a matter of names. The information we provide is the same that Tropomi provides, but the formaldehyde column is mostly in the troposphere, so we just decided to name it total column.
Oh, my apologies. I do see your answer a little further down. Thank you so much. Okay, let's see. Okay, so the next question here is, can you elaborate more about the lines that you pointed out in the NO2 maps? Why is it not seamless?
I can take that one as well. It's just a plotting artifact. Actually, I did it on purpose, trying to illustrate the concept of granules within a scan. But in the tempo observations, there is no gaps between granules.
Okay, thank you very much, Gonzalo. So our next question is, will ground level concentration products be produced?
Yes, so that is an end goal for this kind of data. For people who aren't very familiar with this data, we are measuring total columns typically, other than the ozone profile, which does have some vertical sensitivity. We're providing vertical columns of formaldehyde and NO2. So not the amount at the ground or the concentration at the ground that, of course, we're most interested in for air quality applications usually. This is an active field of research, and there's several Tempo science team members in different universities and agencies who are working on this. I don't know that it will become an an operational product anytime soon, though. That's pretty, if that ever happens, it's quite far in the future.
Okay, thank you, Caroline. So the next question, I'm not sure if this participant provided a bit more specificity, but her comment was, yesterday the script to download multiple files only downloaded one file. Will this be fixed? And my question to the participant was whether or not that was in utilizing the script accessible through Earthdata Search. So we might not be able to address that unless anybody has input on that on the call.
Well, I don't think I can give the answer to that specific question, but I think important things when something, a question like that, I think is a great opportunity to go to the Earthdata Forum that
Yes.
Hazem showed. And a question like that, a technical, maybe partly troubleshooting type question, can be addressed maybe most efficiently through the Earthdata Forum.
Yes, that's a very good point. Okay, so the next question that we have here, let's see, let me scroll down just a bit. I don't think it's been addressed by any team members. Okay, is level 3 data safer than level 2 data to use for data assimilation?
So for data assimilation, you'll want to use level 2 data. For data assimilation and a lot of other advanced applications, you'll need the scattering weights, which describe the vertical sensitivity of the column. So definitely use level 2. Level 3 data does not have any variables that contain vertical levels. So in the level 2 data, there's a priori trace gas profile from the GeoCF model. There's scattering weights and there's a temperature profile. That's not in the level 3 data. In general, level 3 data, I should also just note, is not filtered, unlike, I think Zala talked about this a bit, but you'll have to also filter level 3 data the same that level 2 data is filtered.
Okay, thank you. We did have a question in the chat that I will probably have to look into on my end unless somebody has an answer to this, because I don't know of these plans. Does NASA have plans to distribute GEMS and Sentinel-4 data via Earthdata 2? We certainly do distribute some Sentinel data products across a variety of our data centers through agreements with our partner agencies, but I could not speak to the GEMS, and I don't know perhaps if the science team has any insight into that or has, but otherwise we'll need to look into it if not.
Thank you, Jennifer. There is nothing official, but it's possible maybe in the future if there is like needs from the science community to integrate the data on the same platform, so it can happen.
Okay, we have about 3 minutes left in our extended Q&A, so if there are any questions we do not get to, we will have our speakers follow up with you offline. So the next question is actually also from the chat, and then I'll hop back down to the Q&A. Will level 1 radiances be available during nighttime dark hours outside of twilight? Does the instrument take measurements during these times at all?
So in principle, they will not be available because we are not measuring. There is a limitation on when we can measure, depending on the relative angle between the instrument and the sun. So the answer is no. Depending on the time of the year, these twilight observations can happen, can last longer or shorter, but in the middle of the night, that will not be happening.
Okay, thank you. Okay, so one of the questions is, where can I find the uncertainty in O3 retrievals? Unless you have a different idea. I mean, I think that this information should be available in dataset documentation, user guides, but perhaps the science team may weigh in and let me know, members of the science team, and let me know if you have other references.
So the data product files, the level 2 files include some estimates of the uncertainties for each product, not only total ozone, but also NO2 and formaldehyde. Of course, there is more to it than just the information we provide. There is a question of also of accuracy, but for that is addressed by the validation experiments, and the validation team is working on them. We will put out validation reports periodically.
Okay, thank you very much, Gonzalo. And that will actually be our last question because it's 3:15. We did not get to all of the questions, and I really appreciate everybody's input, both on the polling question responses and also and the question and answer panel, as well as the chat. There's some really excellent feedback here that I will be sending to our speakers and our panelists. And I really appreciate everyone's time this afternoon. Thank you very, very much. At this point, what we'll do is we'll leave the virtual meeting space opened for another 10 minutes or so, but we will log off from the audio component. But before I do that, I don't know if any of our speakers or panelists had any final words to say. And if not, then we'll just go ahead and leave the space open in case you think of any questions. All right. Well, with that, thanks so much, everybody. And we hope to see you at an upcoming webinar. We'll leave this space open. Feel free to type in a question for our speakers. And I should have the recording ready in the next several days or so. And I'll certainly follow up with all of our registrants and provide a link to the presentation slide deck once available for distribution, as well as the recording. All right. Thank you very much, everybody. Have a wonderful morning, afternoon, or evening. Take care now. Okay, goodbye.